don't even know who you're talking about.
Okay, so here's one that we could actually do. Now, if I tell you, you're supposed to solve this, you can cheat on this one. We did stuff like this in chapter 5, and we don't have to solve this by factoring. How do we solve this in chapter 5? Yeah, we square root both sides, didn't we? Right, this is an example where there's a single x, right? And so we can isolate the x by just, reversing order of operations. So what are the 2 steps we would do to get the x by itself? Add 16, good. So we get x squared equals 16. Now what? Square root, good. So we get x equals plus or minus 4, good. Okay, done. All right, now where this gets a little bit, everybody with me?
Yes, sir.
Okay. I'm going to show you another trick. I wasn't really planning on this, but I'm going to go ahead and show you another trick in advance. This will help. So what if I wasn't supposed to show you this till next chapter, and we're going to go into this in more detail next chapter, but I'll show you something right now that's helpful. Okay, so what if we had an equation instead like that we're going to solve? Okay, now this is one where we could factor this as a difference of cubes. We could do that, that's fine. We could factor it as a difference of cubes, or we could do the same process, right? If I want to solve for x here, what are the 2 steps I would do this time? What's first step? Add 343, okay? So we get x cubed equals 343. Now what do you suppose the next step is? Cube root. Yeah, we can do a cube root of both sides. Okay, you got to be careful with this though. We're going to talk a lot more about this next chapter. I don't care if you use this trick now, but you got to use it, with full knowledge of how to use it, because you can use it incorrectly. So if I cube root both sides, I'm going to get x equals the cube root of 343, which is 7. Okay, so, yeah, that's right, 7. Do I need a plus or minus?
Yes.
No, you don't. Okay, you don't. Now, you wouldn't have known that. That was a fair answer. You don't know this yet, but next chapter what we're going to learn is that you only need to do a plus or minus when you're taking an even root of both sides. So an even root would be like an even number root, like square root is the second root. A 4th root would be another even root, right? But a square root, when I say the square root of 9, what I'm really doing is I'm writing, there's a 2 up there on the radical. We just don't write it because it's so common. But that's really a second root of 9. And so that's going to, when we solve an equation that way, we need a plus or minus, right? We don't need the plus or minus for a cube root. So the answer is just 7. Now the other way to do this one, kind of the chapter 6 way of doing this one, which I'll show you, just because this is really the way that the book would show you how to do this one at this point, would be we'd factor that as a difference of cubes. Okay, so we could write this as something cubed minus something cubed equals 0, and my somethings would just be x and 7, right? And so then we'd have to use that factoring pattern, the difference of cubes factoring pattern. Remember that one? See if you can tell me what that one is. A cubed minus b cubed equals what? A minus b, good, times
a plus
a squared plus ab plus b squared. Remember that one? Okay, that's now, if we use that pattern, obviously it's going to work. If we use that pattern, we're going to get a minus b would just be x minus 7 times the other factor is going to give us x squared plus 7x plus 49. So if I were to use the zero product property here, when I set this one equal to 0, I'm going to get back the answer x equals 7. There's my 7. Now remember what we said about this one earlier. This one is never going to give us any real zeros. I could set this equal to 0, and I could use the quadratic formula to solve this. But I'm not going to get, I'm going to get i's, guaranteed. If I were to do this, I won't do the whole thing, but if we plug this in, we'd get negative 7 plus or minus the square root of 7 squared, which is 49, right? Minus 4 times 1 times 49, that's a big number. Agreed?
Yes, sir.
Do you see right away you're going to get a negative number under the radical? So I'm going to get 49 minus some big number, right? And so I'm not going to get any real solutions there. I never will, so you don't even need to use that one, right? That's why you only get one real solution back for a cubic when you cube root something, because the other factors are always imaginary, right? If I go back to that previous example and I did the same thing for this guy, if I factored it, which I could, x squared minus 16, that's a difference of squares, right? I could write that as x squared minus 4 squared. And what's our pattern for that? What's our pattern for a difference of squares? A squared minus b squared equals what? A plus b? Good. A minus b. So then this would factor into x plus 4 times x minus 4, and that gives me my plus or minus 4, right? But once again, I don't care. I mean, if you want to just isolate x, that's what we're going to do next chapter anyway. So if you want to get a jump start on that, I'm okay with it. You just got to remember, when you square root both sides, you need a plus or minus. When you cube root both sides, you do not. Okay? But if you remember that, you're set. What'd I do? Oh, I guess I don't have one. That's all right, I guess. Okay, so so we can probably, now what would I do with this one? Make that a little bigger. Okay, so if I were solving that one, there's just one other additional little detail that's helpful here. What else could I do on this one? Yeah, good. Why not divide both sides by -4, right? Now, because it's an equation, I can do that. I can divide both sides by any number, right? So if I divide both sides by -4, what's 0 divided by anything?
0.
0. So the other side, the right side just stays as 0. The left side's going to get easier. On this side, I'm going to get x squared minus 121. Now what do I do? Yeah. So x would equal.
Wait, no. -44 divided by -4.
Oh, positive. You're right. Okay, so x squared equals -121. Okay, so I square root it now. What's the problem here? Yeah, I got a negative under the radical, so am I going to get any real solutions? Jacob, you guys focus up here, please. I'm not. So then the instructions, you can't see it on here, but they would just say enter n, right? If there's no real solutions, enter n. So that would be a case where we'd enter n. We could also do this one, just like we did before. I could just add 484 to both sides and divide by -4. Say either way, it doesn't matter. Okay? Got those. No big deal. Okay. So those are simple, right? If we're solving polynomial equations that just have a single variable in it, you can go ahead and just isolate x just like you did last chapter. Well, and use cube roots if necessary. Okay. Okay, you guys are you're letting yourselves get distracted. Don't do that. It's seriously, mentally, it's hard to get off track and get back on track. So just kind of, this is like you're resting between sets in track practice. You're just kind of trying to stay focused for the next set. So don't let yourself get off track, or this is not going to be as productive for you. Yep. Yes, you may. Okay, next one. Okay, maybe a little step up this time, but it won't be terrible, you'll see. So what do we do if we're going to solve an equation like this? What's our first step going to be? Okay, combine like terms, set it equal to 0. Right? We're going to put it into standard form. So we get, I got to subtract 9x from both sides and subtract 3, right? So then that's gonna give me, on the left side, I'm gonna get what, x cubed plus 7x squared minus 36x minus 252. Equals 0, okay? So I've got a polynomial equation in standard form. Now here's why the factoring was important, because the way we solve this is we've got to factor it a little bit, okay? So what's our strategy? I've got a 4-term polynomial that I've got to try to break apart into factors. What's my strategy for 4 terms? Remember? Grouping, yeah. With 4 terms, we're going to group it into 2 groups of 2 terms each, and then we'll factor by grouping. So we're going to get then our first group is just going to be the first 2 terms, so x cubed plus 7x squared. The second group will be the second 2 terms, so negative 36x minus 252. Okay, what do we do? What's the next step? Yeah, greatest common factor of the first group. So what's the biggest thing I can undistribute from the first group? Well, x squared. Good. I can't take any numbers out, but I could undistribute an x squared. Good. So if we take out an x squared, what's left behind? X. Good. Because x squared times x would give us x cubed. Plus 7, yeah. Okay, any questions at that point? How we doing? Okay, give me a little 1 to 5 here. 5 meaning I'm in great shape, Mr. Roy, just charge on. Okay, 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 ask a question. Oh, okay, but you're okay with that? Okay, all right. So there's the first group, breaks apart that way. Right now we got to deal with the second group. So the second group is going to have to follow the same pattern, right? We're going to have to be able to break that up into a greatest common factor and a leftover. And what can you tell me about this? What's one thing, Tyson, what's one thing you can tell me about this second group here? What's one thing you already know?
Oh yeah, it's the same as the first set.
Okay, which part's the same? Red or blue? You're getting lots of hints here.
Blue.
No. Blue. Blue. Good. Thank you.
This is what I remember doing.
Good. Okay, so the blue has to be the same if it's going to work, right? So we have to just determine, does it work? That has to be the same, but does it work? Is there something I can undistribute here to make that work? So remember our strategy. We could just say, well, what's got to work for the first term? What times x equals negative 36x? Negative 36. So then does that work if I distribute it to the other one? Is negative 36 times 7 negative 252? Yes, it is. Okay, so it works, right? Okay. All right, so now we're 1 step away. Factoring by grouping leaves us with what 2 factors then?
X squared.
Okay, I'm going to get x squared minus 36 and x plus 7, right? X plus 7 is the common factor, right? Okay, hang on one sec. Eric Oya. Hey. He is not. No. Yep, you betcha. Okay, bye. Okay, so we're essentially factoring out the x plus 7 because that's the common factor. Each of the 2 groups has the blue factor in it. So I can undistribute that, right? That leaves us with x squared plus negative 36, or x squared minus 36. Okay, now here's where this gets easier than having to do the problems you did in the previous assignments. All we're trying to do is find the zeros, right? If it said to factor completely, we'd have to keep going because this is a difference of squares, isn't it, right? But once we get this thing down to where we've broken it apart into pieces or factors that are either linear, so x to the 1 powers, or quadratic, where we have x to the 2 powers, we can set those factors equal to 0 and solve, right? We can always use the quadratic formula if nothing else. So in this case, we don't have to do anything quite that hard, though. We can just set this one equal to 0 and get what result? What's our solution? if x plus 7 equals 0, then x equals negative 7. So that's one of our zeros, okay? Now what if we set this guy equal to 0? Okay, what do we do to solve that one? 2 steps? Plus 36 and then square root. So we're going to get x squared equals 36. So what does x equal? Be careful. Plus or minus 6. So we get 3 answers, right? Separated by commas. 7, 6, negative 6. In any order. Okay?
What happened where it went x squared, all that stuff, down to x plus 7?
To here?
Yeah.
Okay, so this is the last step in factoring by grouping. Once we get it grouped, whatever the leftover factor is, which I always write blue, right? You may not be able to write it in blue, but it's going to always be the one that's left over, that's got 2 terms in it, right?
That was gonna be the same, right?
They have to be the same. And so that means that if I've got this product plus this product, in each of those products, one of the 2 factors is the same. So I can undistribute it or factor it out. So if I undistribute that from those 2 terms, and let's say put it out front, what am I left with behind? Well, I'm left with x squared, that's gone, plus negative 36, right? See how that works? So when I break this apart, it always breaks apart into these 2 factors. Each case will be a little bit different because the numbers will be different, but it's always going to follow that pattern.
So you just take one of them out, like they did.
Well, here's another example that might illustrate this better. Let's pick something easier. What if I had this? What if I had 2x minus 3x, and I want to factor out the greatest common factor from those 2 terms? What would it be?
1.
Well, okay, 1, but can I take out a variable? I can take an x out, couldn't I? Because the x is a factor in each of the 2 terms. So if I undistribute an x, what's left behind? Well, now that's gone and that's gone, so I would just have 2 minus 3, right? That's the very same pattern we just followed, only it looked a little more complicated because the factors were bigger, but it's the same idea, right? Same thing here. I've got, this was a 2 and that was an x, plus that was a 3 and that was an x in the previous example. But because those are the same factors, I can factor it out front, undistribute it, right? Because I've got this red factor times the blue one, plus a different red factor times the same blue factor.
So it would be like x squared plus 49, you don't combine them, you just take them.
No, you can't because they're being multiplied. You can't combine them, exactly. Yeah. Right. Does that make sense? Yeah. Okay? That's the pattern. It'll always be that pattern. And so that gets us, factoring by grouping only gets us down to there. But that's far enough this time. I can set both of those 2 factors equal to 0 and just solve to find the zeros. I don't have to go any further. If I set that one equal to 0, I get the solution x equals negative 7. If I set this one equal to 0, and I solve for x, I get x equals plus or minus 6. So the kind of the strategy is, in a way, you're taking this one great big ugly polynomial equation and you're breaking it into small factors. So when I set those factors equal to 0, I'm getting little mini equations that are easier to solve. Okay? All right. Let's do a few more examples. I think the more of these we do, the clearer this will become. Let's try another one sort of like that one. How about? Okay. Okay, another one. So what's our first step? Combine like terms. Combine like terms. add 4x, I'm gonna get minus 14x. Subtract 9, you get minus 168. So what's I got 4 terms this time in the polynomial. So 4 terms, we know the strategy for that is grouping, factoring by grouping. So we'll group the first 2 plus the second 2, just like always. Okay. Greatest common factor from the first group? X squared. Okay, leaving us with, x plus 12. Okay. Okay, so what do we know about the second group then? What's going to be the same in the second group? The blue group. Okay, the leftover. Well, that's just the way, if that's the way factoring by grouping, that pattern has to work. If that didn't work, I couldn't factor it this way. This is the only way we're going to practice all year for factoring a 4-term polynomial. Okay. This is the one that's the most useful. Okay. So then what would the number be that would work for x then? Negative 14. Okay, does that work for the other one? Is negative 14 times positive 12 negative 168? Yes, it is. Okay, so it works. Okay. All right. So now, how does this factor? What's the pattern here? Okay, so the x plus 12, good. So we factor out the x plus 12, and that's one of our factors. The other factor is made from what's left over. What's left over? Good. Okay, so all I have to do is set those equal to 0 and solve, and I'm done. So what's going to be my solution to the first mini equation if I set it equal to 0? Negative 12. Do we need a plus or minus on that one? No, we don't on that one, do we? The next one we do. Good. So the next one, I'll add 14 to the other side if I set it equal to 0. So I would get x squared equals 14, so x equals plus or minus what? Plus or minus square root of 14. So those are my 3 solutions then, right? 3 zeros. Yeah. Okay. All right. Okay. Okay, this looks a little different. Now, looks a little different, but there's still a way you guys can do this one by isolating x. Okay, there's still a way you can do this. It's a little tricky, but there's a way you can do it. Well, I'm going to show you a couple ways. I'm going to show you the chapter 7 way, which we don't know yet, but you're going to know it soon. I can isolate both sides. I can do that. Okay, how do I do that? What are the 2 steps to isolate x here? So first I add 81, right? Step 1, I get x to the 4th equals 81. Now this is the weird step. There's two ways you can approach this though. This is the weird step. What would you think I would do to isolate the x here? How do I undo a x to the 4th, do you suppose?
Cube root.
Okay, not a cube root.
Quadruple root.
It'd be what we call a 4th root. Okay, so it'd be a 4th root. So I'd be doing this to both sides. I would be. Okay, I'll show you. I'll show you how to do it on a calculator. Okay. It's just that, right? Okay, everybody with me? Okay. All right, so if I take the 4th root of both sides, now what that's going to do is it's going to give me an x on this side. On this side, do I need a plus or minus?
Yeah.
No.
No.
Yes.
Yes, I do. How come?
It's even.
Because it's an even root. Exactly. So I need my plus or minus. And it's the 4th root of 81. Now, there's a couple ways you can do this on a calculator. Okay, here's one way you can do it. If I want to do the 4th root of 81, I can do math right here. See this number 5? It says x root. So if I choose number 5, oh, whoops, hang on. Okay, I have to do this. I have to put the number in first for the root. So if I want to do a 4th root, I would just say 4, and then I would go math, and whatever number I just put in becomes the radical. So I would do number 5, and now that, see where the 4 goes? Goes up to the, it's the index of the radical. Now I do 81, and I get back the answer 3. Okay? So that's how you can do it on a calculator. There's another way you can do it. You can also just, a 4th root is just a square root of a square root. Okay? So I could also just say square root of 81 is 9, square root of 9 is
3.
3. Yeah, but I gotta get the plus or minus. Okay, say it again.
Is it plus or minus 3?
Yes, it is, plus or minus 3. Okay? Did everybody get that second way? A 4th root is just a square root of a square root also. Okay? Okay, now the other way, I do want to show you this just so you're aware. Okay, because this is the chapter 6 way of doing this problem. Okay, so the chapter 6 way would be to use a pattern, a factoring pattern. Now the other ones were obvious, right? We always had a difference of squares or a sum of cubes or a difference of cubes. This one's not as obvious. If I start with the equation x to the 4th minus 81 equals 0, well, there's my 2-term polynomial. Now, which pattern could that match? First of all, we know it's got to be a difference pattern, don't we? Because it's a minus. Yeah, there's only 2 choices. I could do a difference of cubes or a difference of squares. And this is the one we talked about the other day because it doesn't fit a difference of cubes. But I could make this fit a difference of squares. I could write that as something squared minus something squared. What's my first something? X squared. X squared squared is x to the 4th, right? 81 is just 9 squared. And so now I just use my difference of squares pattern. This is just the pattern a squared minus b squared equals 0, right? So that just splits up into a, which is x squared, plus b, times a, which is x squared minus b. Okay? Now I can set those equal to 0 and solve regularly, right? If I set this equal to 0, I get x squared equals negative 9. So when I square root, I'm going to get i's, aren't I? Right? So that one's not going to give me any real solutions. This one, if I set it equal to 0, I get x squared equals 9, so I get my x equals plus or minus 3, just like I did over here. Okay? But don't you think the left way is easier?
Yeah.
I do too. I think you can just do this the left way, because that's the way you're going to do it in chapter 7 anyway. Okay? All right, so let's look at one more of these. How about... Okay, so what about one like this? Thank you. Okay. Okay, have a look, please. All right, this one is a lot easier than the corresponding problem was when we had to factor. Because we don't have to do any factoring here at all. Why? What can we do so we don't have to do any factoring? Kind of. I mean, it's what we want to do here is that. Does that look like a quadratic equation to you?
Oh, yeah.
Yes and no. It doesn't look exactly like a quadratic equation yet because it has next to the 4th in it, right? Now, if it were a quadratic equation, what would the coefficients a, b, and c have to be? Okay, but the coefficients. So a would be what? 1. B would be negative 13. And c would be 42. Okay. So then, if I could just write this as 1, because that's a, right? 1 times something squared plus b, which is negative 13, times something to the 1, plus c, which is 42, equals 0, it would be quadratic. What's the something?
X squared.
That's a minus, right?
X squared.
Bx squared. You see that? If I just group this into pieces of x squared, it looks like a chapter 5 deal, right? A times something squared plus b times something to the 1 plus c. Only the somethings, instead of being plain old x's, are x squareds. But all the tricks we used in chapter 5 work with this because it's quadratic, if we write it that way. So you told me that a is 1, b is negative 13, c is 42. So I could factor this, but I could also use the quadratic formula. I mean, I think this one factors. Maybe. I don't know. Well, let's not though. Let's use the quadratic formula. If I use the quadratic formula, I've always got something equals negative b, so that's 13, right? Plus or minus square root b squared, so that's negative 13 squared, but we'll just make it positive 13 squared. Minus 4 times 1 times 42, all divided by 2, right? Okay, so what's equal to all that stuff this time? No, it's got to be the thing that shows up in the quadratic equation. Well, what is that thing? X squared. It's not x, right? It used to be in chapter 5, we'd have ax squared plus bx plus c equals 0, so x equals, but this time we have ax squared, etc., right? So it's the x squared that's equal to the quadratic formula, the expression in the quadratic formula. So now let's just simplify that, see what we get. So we get the answers, x squared equals 13, so that's 169 minus 168 is 1. I get a 1 under the radical. What's the square root of 1? 1, right?
Yes.
So this becomes, this boils down to 13 plus or minus 1 over 2. What if I take the plus? 13 plus 1 is 14 over 2, so I'd get x squared equals 7. Or, if I take the minus, 13 minus 1 would be 12, right? Over 2 would be 6. So those are my quadratic equation results. Am I done? Not quite, because I haven't solved for x yet. Solve for x squared. Square root both sides, though. That's all I have to do, right? So if I square root both sides, what's this first one going to give me? Plus or minus square root of 7. There's 2 zeros. And this one's going to give me minus square root of 6. Did I do any factoring? No, I didn't have to, right? All I had to realize is that this is really just a fancy souped up quadratic equation. So I can use the quadratic formula. Okay? That's it? That's it. If you can do, seriously, if you can do those, you can do everything in 6-4, which is most of the chapter. Okay? Sure. Let's do, okay, this is the hardest one I could possibly think of. Now, this is a tough one, but you'll see it's not that big a deal.
What have Brady do and all that stuff?
No, you guys.
You wanted it to be.
They wanted it.
Okay, so let's, what do we do here? Combine like terms. Which side should we probably put everything on? Well, that's fine. Right might have been in a way better, because then I could get a positive leading coefficient. Well, that's okay, we'll go left. So if I add x to the 5th, I'm going to get negative. I'm going to get negative 5 x to the 5th. Let's see, I'm going to get, if I add 6x cubed to 19x cubed, I get what? Plus 25x cubed and plus 250x. Okay, everybody agree? Because I added x to the fifth to the negative 6x to the fifth.
Oh, wait. Oh, wow, I just thought it was 5.
Okay, does that make sense? Okay, so now there's one additional piece here though. What do we always try to do first when I'm factoring something? Now that's not quadratic, is it? I've got x to the fifths there, that's not gonna work. But what do I need to do first here? Greatest common factor. I want to factor out a greatest common factor. Okay, so what's the biggest number that goes into 5, 25, and 250? 5 does, doesn't it? Now I always want it, here's a little trick though. I always want to factor out a greatest common factor that has the sign of the leading term. So if the leading term is negative, I'm going to factor out a negative 5. Okay? Can I take out any x's? I can take out one x, can't I? Okay. So I could undistribute or factor out a negative 5x, leaving me with what?
X to the fourth.
X to the fourth. And then this is going to be minus, isn't it?
5 to the second.
Okay, 5x to the second. And then, what's that going to be? 50? Minus 50? Right? Okay, look what we just did. Now we broke this apart. That one's done, right? We got out the greatest common factor. The other factor that we're left with has 3 terms, and we can write this in a quadratic form, can't we? Right? If I just break this one apart into pieces of x squared, it just looks like x squared minus 5 x squared minus 50. Okay, so that's quadratic, isn't it? What's A? 1. What's B? Negative 5. What's C? Negative 50. Now let's try to factor that. It's always easier to factor it if we can because A is equal to 1. So when A equals 1, this is simple factoring. Can we find two numbers that multiply to negative 50 and add to negative 5? 10 and negative 10 and positive 5, right? Now we could have gotten those from the quadratic formula, but that's a lot easier. Right? We can break up the stuff in here into 2 factors with the magic numbers negative 10 and positive 5. What goes here and here?
X squared.
X squared. Oops. It's not red. Okay, so last step then, if that's equal to 0, I'm just going to set each of those factors equal to 0 and solve. Well, when is negative 5x equal to 0? When x is 0, right? Right? Negative 5 times what is 0? Well, 0. The only way you get 0 is if x is 0 there, right? So this one gives us x equals 0. What about this one? If I set that equal to 0, I get x squared minus 10 equals 0, so x squared equals 10. So what's x? Good. Plus or minus square root of 10. Okay, what about this guy? If I set that equal to 0, I get x squared equals negative 5. Imaginary. No real solutions, right? So those are my answers. Okay? Good. If you get that, you're great.